Alrighty, so today we're going to be talking about Chapter 2, Functions and Relations. Hi, Meredith. I hope so. Oh, no. Well, we'll start off with section 2.1. We'll pretty much do this entire unit except 2.2, which is over circles. You will not see circles, so you're okay there. All right, so 2.1, again, is just talking about the rectangular coordinate system. So basically, are you able to graph? Pretty much. Again, we'll be doing this without a graphing calculator. All right, so the rectangular coordinate system and the graphing with graphing utilities and stuff like that. So I'll do an example of objective one. Hopefully this is really easy, but I'm not going to assume anything. Objective one is to be able to plot points on a rectangular coordinate system. So for instance, can you graph -3 comma -4? Here's my coordinate plane. How do I graph that point? How do I get to -3? Use words. Okay, here's the x-axis. But where do I start? Where's the zero? Where's the origin? Red. Right here. It's at there at the center. This is called the origin, which is 0, 0. All right, from there, how do I know to get to -3? How do I know to start at to go left first? That's slope. Think of it like this. You have to right, you have to walk to the elevator before you can go up and down the elevator. So I need to go left 3 because it's a negative, and then I can go down 4. So there's your coordinate, which is called -3, -4. Any questions on how to graph points? Okay, that's the first objective. That is what they've been told. 2 and 4, the even numbers are easy. So hopefully this is pretty straightforward for you. Objective 2, or do we need to do another example? Okay, objective 2. We're going to use the distance and midpoint formulas. So just calculating distance. This is kind of something from geometry. You will be required to memorize these formulas. Nope. So we're gonna find the distance, and then we're gonna find the midpoint between these distances. So let's go ahead and I'll just give you the formula so you have them. To find the distance is basically it comes from the Pythagorean theorem, which basically you have to find the difference of your x, which will give you one leg of your triangle. Find the difference of your y's will give you the second leg of your triangle. You would, of course, square both of them because they come from the a squared plus b squared concept. And then that equals c squared. So to actually find that missing link, you would then take the square root of that result. When we take the square root of something, we don't forget what? Plus or minus. Now, but because we're talking about distance, we're not going to need that negative anymore. It's just going to be the straight up positive version of it because we're dealing with distance. It will, so it doesn't matter. Even if like we wanted to find the yeah, it's when let's say I want to find this distance right here. the distance will always be positive. Even if I was going to the negative side, the distance is always a positive number. So yeah, you can think of it like a lot like the absolute value type stuff. All right. Anyways, so distance formula is as follows. It will be d equals the square root. It doesn't matter the order here, but you want to subtract your x values and then square them. Basically, you're just trying to figure out what is the length of the x-axis that you're using. So you got to find the difference of your x's. You're then going to add it to the difference of your y's. Again, it doesn't matter the order of your x's and y's because you're just looking for the difference. So even if you were to accidentally switch y2 and y1, but you did x1 and x2, the math will all work out because when you square something, what is the result every time? Positive. So again, it doesn't matter if you switch it up, so don't fret about it. Just remember, all right, find the difference of my x's, square the result, find the difference of my y's, square the result, add the two up, and then take the square root of it. All right. So don't stress, oh, is it x1 or x2 for it? Doesn't matter. Just find the difference of the x's, the difference of the y's. Okay. Makes it a little bit easier to memorize because the math just works out for you. Midpoint, I'll go ahead and give you that one before I mess it up. There you go. Midpoint is super easy. If you wanted to figure out the halfway length of something, what would you do? Good. You would literally, if I wanted to know the midpoint between me and Luke, I would literally add our two results where we're at, divide it in half, and now I'm here. All right. So that's basically what we're going to do. So you're going to add up your x values, whatever they might be. So x1 plus x2. And again, this order doesn't matter either because if I'm adding, does the order matter? No, it's all commutative. So if you accidentally did x2 plus x1, no biggie, it works out for you. Just know you need to add up the x's, divide by 2. That gives you your x coordinate. And then do the same thing with your y's. And that will give you your y coordinate. Questions on how the formulas are used. So even though you have to memorize them, it's not too bad. Right? So midpoint, like if you were a coordinate and I was a coordinate, I would just have to add our x values, divide by 2. I'd find the x spot, and then do the same thing with the y, and I'd find the y spot. Yes, this is a coordinate. This is the x coordinate, y coordinate. Yeah, just know that an ordered pair, I have it on the board right now, is x comma y. We do the x first. All right, so let's do an example. We're going to find the distance and the midpoint. So example 1. Part A is to find distance. Part B will be to find the midpoint. All right, in the example we will look at the coordinates 3, 6 and -4, -1. All right, so if I work on distance first, again, you can label if you would like. I think I teach that a lot of times where I'll say, all right, let this be x1, y1, x2, x1, y1, however you want to do it. It's completely fine with me. So if you label this x1, y1, x2, y2, that's fine. Just know where your x's and y's are. So when I do this, also know this too. If you accidentally did your difference of your y's first and then the difference of the x, it doesn't matter because what's addition mean? Commutative. It's not going to match. So this formula becomes really easy to remember as much as differences of both, square them, add them, square root of that result. Right? Remember that process. All right. So anyways, to find the distance here, I'm just going to do the square roots, and then I'm just going to plug in my information. My x1 was 3. So that's 3 minus a -4. What's going to happen there? What's going to happen here? It becomes a positive. If you have a minus a negative, this is really just a positive. All right. So 3 minus -4 is the same thing as 3 plus 4. Okay. plus do the difference of your y's. This time it's 6 minus a negative. Again, what's that going to make? A positive. This is the same thing then as 6 plus 1. All right. So then we just do the math. What's 3 plus 4? So that's 7 squared. 6 plus 1. So that's 7 squared. 7 squared. 49 plus 49. Perfect. All right. Here is the next issue. This is the hardest part. You must simplify this. You must do the factor tree. So what two numbers multiply to give me 98? And 2. Good. 2 times 49 would give me 98. 2 can't go any further, but what does 49 break up to? 7 and 7. How many numbers does it take to pull out? 2. So I pull out a 7. And what's left over? 2. So I have the square root of 2. So your distance here would be 7 square roots of 2. Questions on that? I think the hardest part will just be that factor tree, but I think we did that so much in the last unit that maybe we can continue that process. Part B, go ahead. So I'm okay with that. However, if you notice the way I do my work, I go horizontally. This is called a horizontal line proof because as I'm proving it, it's horizontally, but you'll notice D equals this, which then equals this, which then equals this, which then equals this, which then equals this. So therefore, in my proof, D must equal this. So if you want to go back and add the D, perfectly fine. But if you do it in this format, you do not have to. You will also see the same concept with a vertical line proof where I could say D equals this, and I go equals, there's nothing there, and I write the result here, indicating it's equal to the line before. But again, you don't have to write the D at the end, unless you want to, perfectly fine. So with or without, I'm okay. All right, part B again, to find the midpoint formula. I'm just going to add my x's. So that's going to be 3 plus -4 divided by 2. Add my y's. That's going to be 6 plus -1 divided by 2. All right, so what is 3 plus -1? Ah, dang it. What's 3 plus -4? -1 divided by 2. Can't go any further. 6 plus -1? 5 divided by 2. Can't go any further. So there's your midpoint. If you wanted to write it as a decimal, I would accept it as well. Just make sure it's an exact decimal and not a rounded decimal. Rounded a decimal would indicate a wrong answer. But this would be great as -5, -0.5 and 2.5. Yes, go ahead. I guess you could put M equals. But I'm actually probably good with if you just label B here, and then I would know, all right, if I go to the B part, that's what it is. Any other questions there? Awesome. All right, so let's take this one step further. And my question is going to be determine, so same objective, sorry. Determine, I need a different color. It is. Same objective, different question. I want you to determine if the 3 points form a right triangle. And the points are -6, 2, 3, 1, and 1, -2. Pretty much. So, and it doesn't matter which one you kind of choose there. You could call it however you want to do it, but you need to figure out what is the horizontal distance. So if it helps, let's go ahead and just graph it. We have a visual aid here. So it's going to be 1, 2, 3, 4, 5, 6, up 2, roundabout right there. 1, 2, 3, up 1, roundabout right there. And then 1, 2, right about right there. So I'm trying to figure out, does this guy make a right triangle? What makes something have a right triangle? It has a 90-degree angle. So it doesn't really matter where you're going with this. But I'm probably going to guess that this might be my right triangle in question. So what we can do is we can figure out what is the distance here, what is the distance here, and then apply the Pythagorean theorem. And if the distance here equals what the Pythagorean theorem equals, then they must be a triangle. If they are different, then obviously this is not a 90-degree triangle. So because Pythagorean theorem only works on 90-degree triangles. All right, so let's try this. Let's take this point. They believe this, we'll call this A, C, B. So this was A, B, C. So let's find the distance here from A to C. So from A to C, the distance is equal to -6 minus 3 squared plus 2 minus 1 squared. Do the math here. -6 minus 3 is -9 squared plus 2 minus 1, 1 squared. Yo, sorry. And again, it won't matter the order here. If you would have done 3 minus -6, the two negatives would have made a what? And you would have got 3 plus 6, which is what? 9. Is 9 squared and -9 squared the same thing? Yes. So again, it doesn't matter the order. Got it, gotcha. All right, so then we get -9 squared, which is 1 squared is, and you get 82. I'm going to recommend let's not worry about simplifying this because we're just trying to prove the two things. So we'll just leave it as the square root of 82 for now. Next, we're not trying to calculate the distance as the answer. We're just trying to figure out, is it a yes or no answer, right? So next thing I'm going to do is I'm going to figure out the distance between C and B, or B and C, however you want to write it. It doesn't matter because when I square it all works out. So now it's going to be 3 minus 1 squared plus 1 minus -2 squared, but a minus a negative produces positive. 3 minus 1 is, so I get 2 squared. 1 plus 2 is 3 squared. 2 squared is 4. 3 squared is 9. 4 plus 9 is, okay. I just thought of an easier way than what I was thinking in my head. So this is what we're gonna do next, is let's go ahead and find out the distance of A and B. All right, so let's do that real quick. All right, so when I do this, now I'm doing A and B. Ooh, yeah, I didn't catch that, guys. I did A and B first. Yeah, I wrote -6 minus 3 and 2 minus 1. It's fine. We had to do them all anyways. But that was a big uh-oh. This is A and B. This will be A and C. Sorry about that, guys. All right, A and C. So now it's going to be -6 minus 1 squared plus 2 minus -2 squared. Two negatives make a positive. -6 minus 1 is 2 plus 2 is -7 squared is, and 4 squared is 16. Good. 49 plus 16 is 65. Good. All right. So I don't know. As I was doing the problem, I was doing two problems at the same time in my head as I was doing it with you. And I think this way is going to be way better than what the book's is trying to say. With Pythagorean theorem, C is always the hypotenuse, correct? Which is always the what side? Longest side. Which one of these is the longest? 82. So we automatically know this is our potential C. It's the longest side. So what we're going to do is we're going to do A squared plus B squared equals C squared. These guys don't matter if they're A or B. It just matters that the biggest one's the C. Okay, so let's see. If these equal, when I square them, it's a right triangle. Go ahead. Potentially, right? It should be, right? It should be. It should be. Yeah, and that's my fault for messing that up originally. All right, so here we go. So let's try this. Here is our proof. Our A squared plus B squared equals C squared from our famous Pythagorean theorem. We're just going to plug in the two smaller sides. Two smaller sides. I'm on now. Voice. Talk. Square root of 13 squared plus the square root of 65 squared has to equal square root of 82 squared. So this is our question. Now, what's really nice is what's going to happen to the square root and the square? It cancels out. So really, we are just trying to determine is 13 plus 65 equal to 82? That is our question. What's 13 plus 65? 78. So does 78 equal 82? No. So the answer to this question would be no. These 3 points do not make a right triangle. Just an FYI, and I don't want y'all to get confused. 3 points do make a triangle, no matter where they're at on the graph. But the specific question here is, does it make a right triangle? So do watch out for that. All right. So basically, that was the distance formula 3 times in a row with the Pythagorean theorem added as the is it or is it not? Questions on that? The book tells you to find the absolute value of the horizontal distance and the vertical distance, which could be hard if you don't have a good drawing. So then you're like, oh, this one could be the horizontal, or maybe this one. So like here, I'm assuming this is probably going to be my hypotenuse because it looks like it's the longest side, but I also just hand wrote this graph in. So could be slightly wrong. So if you just find the distance of your AB, your CB, and your AC, you can determine, you know what, AB is the longest side because it has the highest one. But it asks you to find those, and then after the apply the Pythagorean theorem with the distance formula of just this guy, and then see if they're equal. But in my opinion, I think it might be a little bit hard to determine what is the vertical and horizontal, especially if it's not shifted really well. Like, are you going to assume this is the vertical? Or is this the vertical? Because it's not up and down, left and right, you know? And it actually doesn't matter which one you call the horizontal or vertical, but just, I feel like this one's a little bit easier. Makes logical sense. I think that's the key to math. If it makes logical sense, then the whole thing makes sense, right? Alrighty, so if there's no questions there, let's move on to objective 3. Which will be to graph equations by plotting points. First example. Let's see what we got. This would be a great one. Y equals 1 over x. If you remember from pre-cal, I had you memorize all of the parent functions so that you knew what the graph looked like. Now, if you don't have that memorized, that is completely okay. There is a cheat sheet on a way to get around that. What kind of equation is this, though? Can you tell me that? Mm-mm. I'll give you a hint. It starts with an R. Rational. Good. This is a rational equation, which is basically just a fraction. If you recall, a rational function is the one that has the horizontal and vertical asymptotes and has the branches. So I think it's typically like this. You'd also have the branches here and here, both there. Right? So this is what the function looks like. The reason I say this, if you can remember what your family functions are, then you can kind of go, all right, I know what it's supposed to look like. Now, where does it all fall? Well, best approach here is just choose some random points. Best suggestion, choose some that are negative, choose the 0, and choose some that are positive, just to try to see if you can get a good idea where it might be. So I'm going to choose, go ahead. Maybe. A branch? Oh yeah, the try thing. Yeah, because in the calculator, it looks like it's all connected. All right, so I'm going to try -2, -1, 0, 1, 2. You can actually choose whatever points you want. There is no specific points that you have to do. There is no wrong points. You just choose enough points until you have an idea of what it's supposed to look like. So I could do 5 and get it. You might need to do 10 before you see it. It just really depends. All right. So all I did right now is I just chose a couple of negatives, 0, and a couple of positives. I might plug this in and it might not give me enough information. But the key is to know if it's a fraction, I know I have branches. I'm just trying to figure out where those branches are located. Okay. So if I plug in -2, I basically just get -1 over 2, -1. Can I have 0 on the bottom? No. So this is going to be undefined. So that wasn't a good point to choose. Then I get 1, and then I get 1/2. Okay. We good so far? I basically just took the X values, plugged it in, and then just simplified it. Like when I plugged in 1 divided by -1, I got -1. When I plugged in 1 divided by 1, I just got solid 1. Right? If I would have chose 3s and 4s, of course, I would have that fraction and whatnot on there. Right? So I'm going to take this information and I'm going to go, all right, can I graph this and have an idea of what to do with this? So I'm going to go -2 and then -1/2. So here's -1. So arguably about right there. Then I have -1, -1. So arguably a little bit lower than that one. I have nothing at 0. And then I now have a point at 1, 1. And then another one at 2, 1/2. So a little bit less than that. So this is all I got. So this might be like, I have no idea what this shape's making. But if you can remember that a fraction makes branches, then looking at this, I can go, you know what? It's going to make a branch right here where it's not going to cross the asymptotes or the axis, sorry. And the next one's going to do something like this, where it's not going to cross the axis. And again, if that wasn't enough information for you to go, yeah, I don't know how you just did that, then you just choose more points until you go, I see it now. So if I would have chose -3, I would have got -1/3, -1/4, -1/5, -1/6. I'm just getting closer and closer. And then hopefully you go, I remember what's going on now. And if you chose less points, you might want to choose 1/2, which will be 2. If you choose a third, that would have been 3. If you chose the fourth, that would have been 4, and just getting lower and lower or higher and higher. That's the first one I planted. Mm-hmm. And then I planted that one. I couldn't plant 0 because I didn't have enough nutrients. Then I planted the next 2. I say that because I literally started working on my garden yesterday, so it was super fun. A bunch of squash, zucchini, bell peppers, banana peppers, jalapenos, okra. I thought I grabbed tomatoes, but I did not. But then again, I realized I'm the only one that eats tomatoes in my house, so it's not a huge loss. And then I'm gonna do corn and potatoes, and then it's a herb garden. So, but right now we're just trying to do the germinating stage. So I have like a plastic box container thing that you typically have, like an organizer thing, and I just have them in there. I'm just spraying. I'm trying to get them to grow, and then once they grow, I'll cultivate the land and then put them in there. Pretty stoked. All right. Anyways, questions on how to do that. All right. Let's do another example. Example 2, different color. Let's look at this one. Y squared minus x plus 1 equals 0. Now, this actually makes a hyperbola. You might not know that. It's fine. What we're going to do here is you're just going to plug in points and see what it does. All right. I would recommend maybe solving it. Maybe that might help as well. It really doesn't matter. Let's go both the one more time. You can. Yeah, you can use the same points. But the recommendation here is it doesn't matter. I would probably, if I were in your shoes, I would probably do what I'm comfortable with, which is setting it equal to y. So I'm gonna solve it just so I know it's y equals something, right? That's just how our typical equation is. But you don't have to. You can literally go straight into plugging in some points, see what you get. All right. All right, so here we go. So if I do this, what would I do first to solve for y? And good. Get rid of all this. So now I get y squared equals -1 plus x, or x minus 1, however you want to write it. It really doesn't matter. How do I get rid of a square? Square root it. But don't forget what? Plus or minus. So notice by doing it this way, when I plug in an x value, how many y values will I get? You have a positive and a negative. So I'm going to end up with 2 answers. So yes, it doesn't matter the order you do it. So here's a table. Here's my x's. Here's my y's. I'm going to start off with -2. I really don't know where this is at. But I'm going to plug -2. If I plug in -2 here, though, what's -1 plus -2? -3. Can I have a negative inside of a square root when I'm trying to graph? No. So this is undefined. So I'm going to stop there and go, all right, well, if -2 is undefined, what value would I have to start with just to get a real number out of it? You could do +2. I was thinking +1 because what can happen inside? You would get 0. Can you take a square root of 0? Right, it's a 0, right? So I'm actually going to start with 1. You could start with 2. It doesn't really matter. But I notice if I at least start with 1, I'll get a 0, right? So if I plug in 1, I get 0. Square root of 0 is 0. All right, so there's one good coordinate. I'm going to at least try to get 5 so I have a good idea what's going on. Then I try 2. But when I plug in 2, what's 2 plus -1? And then the square root of 1. But I have a plus and a minus. So that means I have 2 at a 1 and I have a 2 at a -1 because I have plus and a minus. I don't know. We'll have to see. Let's do some more. Let's do, I'm going to not do 3. Here's the reason I'm not going to do 3. What's 3 minus 1? Do I know what the square root of 2 is? No. So I'm going to try 4. What's 4 minus 1? Do I know what the square root of 3 is? No, I'm not going to do 3 then. Let's do 5. 5 minus 1? 4. Do I know what the square root of 4 is? Good. Let's stick with good, nice numbers. We're trying to develop a good graph that I know how to do without a graphing calculator, right? So if I plug in 5, I get 5 plus -1, which is 4. Square root of 4 is 2. Good. So I have 5 equals 2, and I also have 5 equals -2. That's 4 points. That might give me enough to figure out what the heck's going on. It might not. I might have to go back and do some more, but let's see what happens. Here's my coordinate plane. I start off with 1, 0. So here's 1, 0. My first point. Then I have 2, 1 and 2, -1. Interesting. Then I have 5. So that's 3, 4, 5, 2. and comma -2. Can you kind of see what might be going on? What do you think's going on? Okay, okay. It is a hyperbola. A hyperbola is basically a parabola sideways. Oh, parabola is the word. Yes. So this right here is actually going to do that exact thing. This is a hyperbola. There you go. Yep. And if that wasn't enough points, just keep going until you go, okay, I get it now. Right? That's it. Right? And again, you didn't have to do this. You could have just strictly plugged it in, but then you would have been solving for y for each one and got the same outcome. I feel like here, if you solve for y and just plug in your x's, you can just PEMDAS it until you get an answer, and then you're done. In my opinion, that seems easier. That is, it is. All right, so let's talk about the last objective. Objective 4. All we're going to do here is we're going to identify the x and y intercepts. Can you tell me what makes something an intercept? Good. An x-intercept is where it will cross the x-axis. Y-intercept is where it crosses the y-axis. Simple enough. Oh, no. Let's look at an example. Midpoint? No, no, no. We're not doing midpoint. I guess I have no idea. Are you trying to tell me? Are you telling me slope? X1 minus or Y2 minus Y1 over X2 minus X1? Yeah, we'll get to that tomorrow or Wednesday. All right. In this situation, you're given an equation. What do we know about x-intercepts? What's always true about x-intercepts? Good. If it crosses the x-axis, what do we also know will always be true? What will be for the y? Yes. So for x-intercepts, we know y will always equal 0. So that's all we're going to do. We're going to plug in 0 in for y and solve for x. So I get x squared equals -0, because again, I'm plugging in 0 for y, plus 16. Well, what's -0 plus 16? Just 16, right? There's not such thing as a -0, so it's just 16. Now what would I do? Not divide, square root it, right? But then again, when I take the square root of something, what am I not going to forget? Plus or minus. So my x-intercept here would be plus a -4. For me, totally accept this. For your homework, it might be more like this: 4, 0 and -4, 0. They might want you to write it as an actual coordinate. So here's your x values, and then just plugging in 0 for y. Make sense? All right, so for x-intercepts, if we know y to always equal 0, what do you think is going to happen with a y-intercept? X will always equal 0. So we're going to do the exact same thing, except this time we're going to plug 0 in for x, solve for y. So we get 0 squared equals -y plus 16. Well, what's 0 squared? Just 0. So I really just have 0 equals -y plus 16. What would you like to do next? Go ahead and swing the y over, right? If I add y to both sides, I get y equals what? 16. Again, I'm okay with this as the answer. On your homework, they would probably want you to write it as a coordinate. Is there any questions? I think that's about it. There is an objective 5, but it's using a graphing utility, which you are not allowed to have. So those should be removed from the homework. If you do run into those, please let me know and I will delete those questions. But I think I did that last semester, so it should be good. Yep, so you won't need to know objective 5. So that's it. That's all I got. Neat. If you want, you can go ahead and start working on the homework if you like.